So now we're going to start the first plenary of the summit, the first keynote, which is by Rico Malvar. And Rico Malvar is going to talk to us about the recent advances in information technology. So we had already an introduction by Paula. Let me maybe just redo it a little bit and put some information now in English. So Rico is a Microsoft Distinguished Engineer and he's a Chief Scientist at Microsoft Research based in Redmond. And he's currently leading a new team which is developing technologies to help people with disabilities. Rico has been with us for many, many years, I think almost 20 years.
Yes.
And actually he's been, I think, part of all, pretty much, I think, all of them, of the Latin America Summit. Yes. So he's definitely a friend of us as it comes to Latin American Summit. He has also, when he started actually at Microsoft, he was working on signal processing, and a lot of the technologies and the research that he has been leading with his team has found their way into products at Microsoft, such as Windows, Xbox, Office, and more recently, some formats he's been working on which are being used by Skype, Netflix, YouTube. Rico is also an IEEE fellow, receiving many, many awards. And more recently, he has become the he received the Technical Achievement Award for the IEEE Signal Processing Society. So with that, please let's give a warm welcome to Rico for the first plenary of the summit. Thank you.
Obrigado, obrigado. Obrigado, Evelyn. Thank you, Evelyn. Então, desculpa vocês, mas eu vou passar para inglês porque é melhor para os brasileiros, porque vai ser melhor para a audiência. So, I'm going to go in English. I think it's easier for everybody if I do so. So, I'm going to talk to you a little bit about advances in information technology, but of course, this is going to be a biased view. This is not a view from the whole world, a view from Microsoft Research. So naturally, I will try to show you a few things that are very much related to how Microsoft Research is driving advances in information technology, all right? So we tend to say that it's kind of a golden era for research. I touched on that briefly before, because now we have this whole capacity of cloud computing together with devices. That's why, as Paula said, the company has this motto, mobile first, cloud first, because both matter, and that's how we can build very powerful things, combining the computing of the device you have with you with the enormous computing that's behind the cloud. So you're not limited to the capacity of the device in your hands. There's so much more you can do, as long as there is a big cloud to support that. And it's very important for the company and for other companies as well to invest in that cloud. So Moore's Law is kind of ending. I mean, there's some argument about that, but we're not going to have Moore's Law running for 5, 6, 10 more years because the cost of producing chips will get unbearable. At some point, when the cost of a factory gets to $15 or $20 billion, then it's going to be hard to build such a factory. So what we're doing now is inventing new ways to create new architectures, different architectures for the computing chips. So even though the size of the number of transistors on the chip is not going to grow by Moore's Law anymore, but we can still grow the number of processors in a computing architecture and get a lot of power out of that. And I'll talk a little more about that. Computers that can see, hear, understand. I like to highlight that because we're actually going through a big change, and many of you are living through this change already. Your grandkids will talk to you and say, what? Did I have to learn how to use a computer? What is that? I just talk to a computer, right? I just ask the computer for stuff, and the computer does stuff for me, right? There's no such a thing as learning how to use the computer. So that's the thing that we really want to drive. And artificial intelligence, machine learning, natural language processing, those are the technologies that are going to create that shift. The computer learns to interact with us, not the other way around. And then computer gets to be more fun. right? Like, for example, when you have your little device, tablet or phone that tells you, oh, your next meeting is far away from here and traffic is bad. Don't you want to leave a little early? So anticipates your needs, does things for you, and talks to you in your language, not you talking in the computer language, right? So one model that I want to share, one specific thing about Microsoft Research is what we call the quadrant model. Microsoft Research has about a little over 1,000 people all over the world in several laboratories. As Paula said, we have even a team here, and I see members of our team. The director is here, Luis, Leonardo is here as well, in Brazil, and we have all over the world. And we do lots of collaborations. We do research in many areas, and we also manage research in many different ways. If you ask me, what's the right way to manage research? I'll say, there's a bunch of them. There's no such a single model that works for all kinds of projects. In fact, there's a whole variety of them. But we use this model as to give you an idea, just to cluster all these models in what we call the 4 quadrants, based in 2 dimensions. One is whether your research is open-ended or if it's focused on a particular well-defined problem. That's the vertical axis. And on the horizontal, whether you're trying to do something on schedule, oh, I really want to finish this within a year or within 2 years, or if it is unscheduled, right? So, and then we divide these quadrants as blue sky, disruptive, mission focus, and evolutionary. So let me look at the 2 extremes just to explain to you. For example, mission focus on the bottom left basically says, I have a specific problem to solve and I really want to do it fast. So usually involves a good combination of advanced research and some engineering to try to make that work. On the top right is that I don't know when I'm going to do this, and I actually don't know very much what am I doing. So it's very open, very open-ended. That's what we call blue sky. So a good research organization should have some amount of blue sky research, even though it shouldn't be all blue sky research. It should be just part of the portfolio. And if you ask me, do we spend exactly 25% of the time on each one of those quadrants? No. It varies over time, but we have a fair amount, significant amount of projects in all these areas. So just to give you an idea, a good way to drive a collection of research projects, which can apply to a company, can apply to an institution that is trying to foster research, some kind of support organization like CNPq here in Brazil or many others. Try to drive a portfolio like that, because you never know where the most benefit is going to come from, right? So just to give you some examples of some blue sky research. Machine learning algorithms. In the past decade or so, the new concepts of deep neural networks came up, and the first driving for the researchers, not just at Microsoft, but the whole community, in those were like, wow, if we use these very big neural networks, we can make these classifiers that can learn all kinds of stuff. What are we going to do with all of that? I don't know, but let's build them anyways. It turned out that they became fundamental to do speech recognition at the level we can do today, including enable things like speech translation, which I'm going to talk about later. For example, in the middle, and I'm going to talk a little more about that project, is what if I can actually model, pick a system that can see in 3D your hands, and then build a model, as you can see in green in the bottom there, of where your hand motions are going, what you're doing with your hands, and being able to capture the fine movements of your finger. What can I do with that? I'll talk a little more about that. And so forth. For example, theoretical developments in math, computer science. A few years ago, we had a major mathematical theorem having been proven at Microsoft Research, one of those things that takes 100 pages to do so, and you say, wow, what am I going to do with that? I don't know, but maybe at some point. It's still part of blue sky. On disruptive, I don't need to tell you about HoloLens. You all heard about HoloLens. The core idea behind HoloLens is, if a computer wants to show me something, why do I have to look at a display like that? Why aren't displays all around me? Why can't information be all around me and related to the other things in the physical world? And that's what HoloLens does. I'm looking at a person, oh, that person is Luis. If I had forgotten his name, then HoloLens could tell me, oh, this guy sitting over here, that's Luis. And he actually reports to you, so you better know his name. So, and so forth, but it is disruptive. For example, on the second one, artificial intelligence bringing you new things. Not just the idea that I can recognize that there is a person in a picture, but who's that person? And in that one in particular, all dimensions of emotions. What are the emotion features? For example, the system is telling that in that particular picture, the lady seems to be somewhat happy, somewhat neutral. That might be an okay description of Mona Lisa, right? So the idea that you get more semantic, higher level information from the data you have at hand. So machine learning, artificial intelligence can bring you, or can bring these disruptions and enable you to do things you couldn't do before. Like in Skype, we just shipped in Portuguese a few months ago real-time speech translation capabilities. And please stick around because we'll present more about that, and we'll have a demo of the system in our demo session tomorrow. And the idea that you can translate speech in real time can open all kinds of new dimensions. For example, we broke the barrier of distance with Skype. You can call people all over the world for essentially nothing. And now we're going to break we are breaking the language barrier. You want to talk to somebody in India, you may not, or China, you may not be able to speak Chinese, but through Skype translator, sure, you can have a conversation. Some mission-focused thing, which I like to mention that because it touches on what I mentioned before, Microsoft Research really trying to help the business as well. For example, databases. Making databases faster, run faster, is an important thing to the company. We sell database products and systems. It's important for the community. Databases are used for all kinds of things. If we can make them faster, that's a good thing. And recently we did a hackathon project that the latest version of SQL Server supports that, which basically lets a lot of the engine run in memory. Because now you can easily have a computer that has 1 terabyte of RAM, for example. Then you can run everything, the query processing, everything in memory, and some jobs can run 50 times faster. But it's more like, as I said, mission focus. I want to do it fast, and it's an incremental advance. And that can applies to other things as well. Catapult is one that is really important, which is making the cloud more powerful. Because as Paula said, it's not just about having the cloud, but having an intelligent cloud, which can really do good things. But intelligence costs a lot of processing. So a lot of what we're doing with machine learning has deep neural networks, which actually require a very large number of operations to run even small things. So unless I build a very powerful cloud, there's no way I'm going to build an intelligent cloud. And I'm not restricted to just buying computers from whoever sells computers. I can make my own computer. I'm making this presentation from a laptop that is designed and produced by Microsoft, for an example. But in the cloud, if we're putting in the cloud hundreds of thousands of computers, and in fact millions of computers in the cloud, I can actually design whatever computer I want because I have economies of scale to justify specialized. So the Catapult project, I'm going to talk a little bit more about it later, actually uses FPGA, which is a different kind of architecture, to bring the computation efficiency in terms of how much electricity gets in and how much computation you get out, sometimes to a factor of 50 or 100 times higher. So that what enables you to really do an intelligent cloud because you have a very powerful cloud to begin with. And so forth. For example, some of them are evolutionary. I talked about natural language processing. I'll pick an example here, the example of the latest version of Office. I just took a little bit of a screenshot of the help window that not many of you pay attention. But if you're especially if you're a powerful Microsoft Office user, you may not have noticed that. But sometimes when you have a sophisticated application, such as Microsoft Office or others, and you need to ask for help, the help system is a gigantic thing. And when you ask for help on anything, you get all these many links on things, and you can be lost. In what we've done recently by using natural language, you just go there and type. What is that you want to do? I want to change all my section headers to boldface. You literally say that in English, in human language. And then Office can come to you, change all the section headers and say, is that what you want? You say yes. So you didn't have to go to a menu, drop down, select, and do all kinds of things. You just expressed in human language what you wanted to do, and the computer was able to understand and perform that for you. Sounds like a small thing, but if you're dealing with documents on a daily basis, a small improvement of every document that you try, it's going to save you hours of work every week. So it does make a big difference, right? Another thing I want to highlight, I've used this slide before in a presentation I did in São Paulo last year, but I want to bring it again exactly as it is because it has an important message. Have any of you heard of Kinect? Hey, okay, you all have heard of Kinect. Many of you are students. You may have played with the Kinect SDK. Of course, you know what Kinect is. Do you know a little bit about the history of Kinect? I'll tell you one bit about it. 3 years before it got launched, another Brazilian who's a technical fellow at Microsoft, Alex Kipman, came to us and researched, Rico, we want to do this Kinect thing because the video game controls are evolving and we need to get an edge, we need to push Xbox ahead of everybody. What if we didn't have a controller? What if we just do gestures and voice and that's how you control the game? Can you do that? And then I put together a meeting with Alex and researchers and they told me, no. Say, okay. But Alex didn't want to hear no as an answer. So he kept pressing on us. And then by the third time, we were like, okay, maybe we can do it. And then we realized, wait a second, we actually can do it. And that's what the slide says. We've been doing microphone arrays for 15 years. We've been doing computer vision for so long. So that the idea that you can have a device that can actually see in 3D and differentiate the people in front of you, build skeleton models, as we're showing here, of what the people are doing, and filter the voice in a way that even in the middle of the game, if you want to stop the game in an Xbox and it's playing with Kinect, how do you stop the game if there's no button to press? You just say, Xbox, stop. Right? And it responds to that, and it stops the game because you may want to do something else and pause the game, for example. Right? But then you need an array of microphones because you need directional hearing because more than one people may be speaking. You want to filter out all the noise that the games themselves are playing and all of that stuff. So the day we decided that with that critical meeting with Alex and say, do we want to do this? We realized that we actually had the assets. Not only that, it took a lot of research to develop that. So a message for you guys. Research is a long game, and it does matter. And you can bring disruptions such as Kinect by leveraging on a lot of very high-level, very sophisticated research on computer vision, signal processing, systems, all kinds of things that you need to put together to create a device like that. So sometimes what appears to be more theoretical can be more applied, right? So as I mentioned before, with this idea on the Blue Sky research, the researchers developed this system, and we just published this a few months ago, where you can actually figure out what you're doing with your hands, a sensor, and the sensor is actually Kinect. Using Kinect, we can actually model what your hands are doing. How do you control a computer today? You type in a keyboard, you touch on a screen, you use a mouse. What if you could do gestures in the air? So let me show you an example of the system.
We present a real-time system for tracking the continuous articulated motions of a user's hand with only a commodity depth camera. Our system can reconstruct the complex articulated pose of the hand whilst being robust to tracking failure and supporting flexible setups such as tracking at long distances without over-constraining the user to close-range forward-facing scenarios. Our system offers new levels of robustness and flexibility for interactive applications.
So you see the virtual hand is being controlled by your hand, which is not even touching.
Here we show a wide range of poses that our tracking algorithm can reconstruct. Notice that our system can deal with fast motions
as you
and
can
can
see,
recover from
what do we
tracking
do
loss.
with all of that? And you can
It
see
can
there
also track
examples,
whilst the user is
right?
moving and at extended ranges beyond existing hand tracking
Let me just stop the video for a sec. Right? So if you were to ask, what can I do with this technology? The images on the bottom show you some examples. I can actually now think about things and do gestures in the air to control the things I'm thinking about. Imagine a doctor who can now operate all the instruments, doesn't even need to take his or her hands off, the gloves off. While with the gloves are in the middle of a surgery, can control all the information technology associated to that. Imagine sign language translation. If I can detect your gestures, I can probably do a reasonably good job. And you imagine, are we thinking about that? Yes, of course. But further beyond that, today, do any of you use touch on a surface of a device to control that device? Yeah, I'm kidding. Of course, all of you do that. As soon as touch was reliable enough, you can't go back. You have to use touch. And what I predict to you here, and it's risky to make predictions, but I'll make one, is that we're going to do touch at a distance. And once it works, we can never go back. Which means if a computer is farther away and I cannot reach and touch it, doesn't matter. The computer can see my hand and I can control from a distance. Once I can control from a distance, I'm not going to go back. It's going to be a new mode of controlling computers. And there's a lot of research and a lot of research in computer vision, machine learning, graphical models, and geometric modeling as well that goes into building that technology, but it enables a new form of interaction. So yet another example of new kinds of interactions with the computer. So I'm going back now to the Catapult project I mentioned to you before, because this is actually super important to us. As I said, we have today in Bing, we are using those new computers. We basically pick up, for those of you who understand how data centers are built, you pick up these rack computers, you take up this blade, which is this big board of many processors. What we did, we put a coprocessor in that. Sometimes people do coprocessors with GPUs, for example. GPUs, you can have 700 cores, 1,000 cores, and it can do a lot of computation for you. With the FPGAs, you can actually make the hardware programmable. You can have code that controls very small pieces of hardware interconnected inside a chip, which allows you to now have 100,000 cores, 200,000 cores in one chip. Now you put several of those chips in a blade. You have several blades on a data center. Now, the economies of scale, you're getting to billions and trillions of processors doing things for you. So Bing brings computation to a new level, sometimes 50 times faster. So some things that Bing has to do that take days to run, they will now take hours to run. Some things in your practical life, in your business life, that take a lot of time to run, they will run much faster. The cognitive services that I will mention later will run much faster on an architecture like that. Another example is security. I claim that if anybody has a question about, is the cloud secure? Well, the cloud is more secure than trying to do computation in a premises, because at the economies of scale, I can have the data centers replicated, so a data center can catch on fire and you don't lose a bit of data because it's being replicated in other ones. Physical access to that data center is much more controlled than physical access to your typical company. So nobody's going to go in and steal the data from a hard disk. And we can have actually stored the information in the cloud totally encrypted in a way that only the user holds the key. So the user has to give the key to the cloud for the cloud to be able to use, which means if any other entity comes to the cloud provider and says, I want to have access to the data of that user, it can't happen because the cloud provider, for example, us, for example, Microsoft, cannot decode the data without the key from the user. We have to go to that entity without naming who that entity would be and say, sorry, I cannot, no matter what legal terms you may have, I cannot give you the data of that user. You have to talk to the user, right? And in fact, one thing we're doing recently with the advances on cryptography, there's this thing called partial homomorphic computing, which allows you to do some kinds of computation on data that is encrypted. So you can have, for example, select fields on your database that you want to process on. I can do the selection in the cloud on data that is encrypted without having to decrypt based on the rules you gave me during the query about selecting that data. I don't have time to explain that here here, but it actually works. You can do some level of computation on data that does not need to be decrypted. But of course, you can only see the result of that after you decrypt. But I can do things like data selection and some other things in the encrypted domain. And again, with that, I can build a cloud that is super powerful, much more secure than anything else, and now intelligence, because of what we're going to say later. So when you have things like Azure Machine Learning, and Paula mentioned, for example, the program Azure for Research, where we bring this capability to you, this is just an example of a diagram that shows that you can build powerful applications in a just like as you do with Visual Studio. You can do things in a very easy way. The integrated development environment is very easy to use these things. And now you can tap, for example, you can make, with a few lines of code, you can call an API that will do data classification for you, that will find new clusters of data for you. If you have your own machine learning algorithm that you've spent years developing, let's say in the language R or Python, you can easily integrate those so that now you can build an API that calls your preferred algorithm, not the ones you have. If you're not an expert and you just want to use deep neural networks, fine. Just call our APIs and you can now apply the power of deep neural networks to your applications, right? So let me mention, for example, cognitive services, which is something that the technology and research arm of Microsoft is putting a lot of effort on, which is really a big step, as Paula said, of the intelligent cloud. And you can go to www.microsoft.com/cognitive. We're now in beta testing a few things, and hopefully by the summer, or, I mean, I'm not in the product side, I can't give you dates, but very soon these things are going to be available as systems you can integrate in your applications. But the idea is to be able to bring different kinds of data, like speech, natural language, images and video, and the cloud can do intelligent analysis on that. As Paula said, the lab in Brazil, and I'll say a few more about that, is already doing something along those lines by doing analytics on video. You can do things like, for example, send a piece of text and ask the API to translate that to speech for you. You can send some text and ask the API to tell you what's the emotional content of that text. For example, imagine that you build an app where in your app, your users go and write a bunch of comments. And suddenly you have this log of all these comments that people typed in by text. You can use the emotion APIs and go in and see, are those positive comments? Are people happy what they're seeing? Is there positive comments about this topic, but maybe negative comments about that topic? So all that intelligence the cognitive services can do for you. So you don't need to worry about writing a bunch of code to analyze the text that you're collecting in an application, for example. So in the idea, in the good spirit of Microsoft, is build a set of APIs, a platform that allows you to tap on all these capabilities. And that's what it really means to build an intelligent cloud that can bring you all of this for you. You can build small apps that are incredibly powerful because they have this intelligent cloud behind them, right? For example, CaptionBot is something that we just launched recently, still in beta, which goes beyond the idea of just telling you something that is in an image. For example, are there people in an image? Is there a face in an image? Probably even your phone or your camera can do that, right? It can identify faces. Can you say who's that person? But can it make a more meaningful description of what's in an image? So what CaptionBot can do is, for example, you put that picture like that, and it will produce the caption, I think it's a herd of cattle standing on a field, right? So you can see there's now a different level of semantics being done. There's more than one animal. It said cattle, so you say what kind of animal. On a field, so it's not just a bunch of green pixels, it's a field, right? So we can bring that level of intelligence. Another one, you put the city of Seattle, I think it's a city with tall buildings. Didn't catch Seattle, but it did catch that it is a city with tall buildings, right? Another one there, since we are in Brazil, we do love football here. I think it's a group of men playing a game of football, and they seem to be not happy, right? That's not necessarily what you wanted to learn about that picture, but it's a reasonable way to describe the picture. And you can imagine what you can do with that, both on the fun side of life and also in the professional side of life. On the fun side, do any of you take pictures? Do any of you take pictures of your phone, with your phone or camera? Do any of you take thousands of pictures with your phones and your cameras? Now the key question, do any of you really see all those pictures afterwards? After you posted on a social network or sent them via email or some text messaging interface, do you actually see them? Because it's hard to find them. Usually you put in a folder by time or by place or something. It's very hard. Now you can imagine if for each picture I can create a description like that, I can now index them for you. And then later I can build a very powerful retrieval system based on all the semantic metadata I had about the pictures. So imagine that now for an insurance company, for all other kinds of potential applications where you have collections of pictures, and now the captioning can help you index them at a much higher level than you could do before. And this just started. The system is very brittle. Sometimes it produces a beautiful description, sometimes it misses it because it's an evolving technology, but it's exciting to see where you can go with this intelligence over images. So Paula mentioned our lab here in Rio, the Advanced Technology Lab, and in collaboration with the other Microsoft research labs, and in particular with the Cognitive Services team, the lab here is doing some very interesting things about analytics in video. What do you want to do in video? For example, you want to identify people, who the person is, if there is a person in the picture, what kinds of things the person are wearing. Are they wearing a hat? Are they wearing a helmet? I could be like the policeman that looks at video of motorcycles. If you go by a motorcycle and you're not wearing a helmet, I say, oops, ticket for you, you're not wearing a helmet. I mean, I'm kidding, but you know, all kinds of applications like that. General behavior, for example, if I'm in some kind of public area and somebody is walking in a way that they seem to be injured, for example, if they start tumbling or walking like this, can the system recognize and raise a flag? Look, there seems to be a person in trouble in your environment. The same applies to cars. Can I identify the vehicle? Can I identify the plates? Plates is actually very easy. Today, commercial toll systems are already do the tolling just by reading the, you don't need any device in your car or anything. It just reads the plates of the car and then you get a bill later. But what kinds of cars? And is the traffic pardons reasonable? For example, Rio and many other big cities have a lot of traffic issues, and you can, by doing video analytics, identify specific patterns. Oh, the traffic's bad, but it's normal bad. Or there's a really bad traffic in here, and there's these kinds of things happening. Or some robbery has happened in a bank, and it was a blue van. Where's that blue van going? Let's search for the blue van. All of those things you can do. So the lab in here, for example, picked this technology, implemented it in real time, so now the system actually can track vehicles and detect events, what kinds of vehicles are going by. Are they stopped in the middle of the road? If a vehicle stopped in the middle of the road and they're not supposed to, it's a good idea to set a flag to say, oops, something is happening here. And Luis was just telling me that after about a year of work on this, the precision of the events is very high. It's above 95% that you can get that the flags raised by the system actually do correspond to notable events happening in real life. And they've also integrated that on a bigger, Paula mentioned the detector system, where we can actually correlate the video events with other kinds of events, data that I may know about specific events that are happening, or that I know there's going to be a gathering of people at some point, and all of that can be put together in a panel that allows, for example, police departments, like in the state of São Paulo now, the system is running 24/7. Generating events. It doesn't generate events all the time, but it's running all the time, collecting data all the time, and at prescribed intervals it will generate events, and now the police department can use that for a much higher level of intelligence of what's happening in the city, right? So I want to close here by talking about an area where we started to do more, which is an area that I'm particularly a little more involved on, which is accessibility research, the idea to use technology to help people with disabilities. Remember the mission of the company, as Paula said, empowering every person. Now let's highlight every, right? So if you have a disability, having a normal life can be a difficult thing, right? And technology can help compensate. If you have a sense missing or a capability missing, maybe technology can help you with that. So I want to talk briefly about 3 projects that in those. It's not the only ones we have, but those are relatively recent projects in this area. One is guide dogs, and you can see an example here where the lady is wearing a special kind of headphone, which called a bone conducting headphone. It's not produced by Microsoft, it's a partner of ours. It does not block your ear. It does not block you from hearing the environment, but can add to it. But if you're blind, the system now can guide you to some points, because we can use the 3-dimensional audio technology that Ivan Tashev will be describing to you in our demo session. Please stop by there, to actually play sounds anywhere I want. So instead of the sounds being in your head, the sounds will be in the environment. And the system basically says, follow the sound. You follow the sound because the headphone also measures the position of your head. And by following the sound, instead of following a map, which is displayed, which you can't see because you're blind, you can follow the sound. So it can guide you by sound. And this picture was taken in the train station in Reading, a city near London in the UK, where we've instrumented the train station with additional Wi-Fi hotspots, because now the system can guide you within a building. So not only I can tell you how to get to the train station, once you're there, I can tell you how to get to the precise gate where your particular train is going, right? So now you can't see, but you still should be wearing a cane and other things that you've been used to, but now I can give you additional information, right? And this is just an example in the middle of the city of Reading, a person going around. And we can also do things like, because we know what the city are, we know where the locations are, and we know where you are, we can tell you there's a coffee house to your right, and then you walk to the and I can ask you, do you want me to guide you there? If you say yes, I can guide you to get to the coffee house. So it brings a new level of independence to people. Another one is seeing AI. Imagine I'm wearing glasses just like this one, and again, a partner company makes those glasses. In the middle of the glass, there's a small camera. So you put that glass on, imagine you're blind, but now the system can see what's in front of you and can tell you things about what's the world. So there's an app on the phone, so even though you can't see the screen, you can touch the screen. And muscle memory is enough for you to know if you're on the top of the screen or in the bottom of the screen. So, and by that, you can do things like, for example, suppose there's a big sign in front of you. The system can read the sign for you, so you know what's in that sign. So it gives you a new level of comfort. You don't have to ask somebody, is there a sign in there? What does the sign say? If there are people in front of you and they are smiling, the system can actually tell, these people are in front of you and they're smiling. And then you can make a comment. Oh, you seem to be smiling. What's the joke? They're going to have a kick out of that. You can say, how do you know we're smiling? Right? Imagine the bump in quality of life that we can bring to people, right? Another project that John Campbell will be talking more about, and will be in the demo session as well, is imagine people would have motor neural diseases. Imagine you're in a situation, for example, folks who suffer from ALS and similar diseases, where you cannot move your muscles, so you're bound to a wheelchair, you cannot move anything, you cannot move your vocal cords or your vocal tract, so you cannot speak. Your brain works very well, your muscles don't. So how do you communicate? It turns out that in most cases, the muscles that control the eye don't get affected. You can still move your eyes. And now, by using inexpensive sensors that can, very similar to how Kinect works, by using infrared, they can actually measure where your eyes are looking at. And we can actually display, and John will tell you more about that in the demo session, we can display a screen, and you can gaze at the letters of the keyboard, and you can actually type that way. You type with your eyes, and the keyboard at the top right has a play button. Once you typed what you want, you press the play button, and a speech synthesizer, just like the ones we have in the cognitive services, will speak that sentence out. And in fact, that makes that is a life-changing technology to a person. Instead of being locked and not being able to communicate, now you can communicate with the system. And as John will tell you tomorrow, you can actually communicate at a good enough rate that you can maintain a reasonably good conversation. So for these people with this kind of deficiency, a system like an eye gaze keyboard really makes a big impact in their lives. Okay, with that, I want to close, and I just want to reiterate to you that it's really exciting to be working in computer science and related technologies. See how information technology is changing the world we're living in very much in many ways and changing the lives of users, for example. So for all of you in academia, all of you have interest in computer science, keep pushing because we're going to do a lot more, and the world 10, 20 years from now is going to be very different from what it is today. Thank you for the opportunity to talk to you.
Thank you, Rico. Thank you for this great talk. I think it really shows how industrial research can help advance science and also having real impact in society. So we have some microphones in the room. So if people want to ask questions, please, yes. While the mic comes, so we have also actually in the audience quite a few students, and I want to pick your brain on and just recommendations for the students in the room on what should they become specialists or generalists. And when we look at AI in particular, which is the topic of this summit, a lot of, there are examples like the Kinect examples that you gave where actually there are different experts in different areas who work together to make a scenario come to reality. Then you gave, on the other hand, you gave examples like the cognitive services where now if I am, let's say, an expert in natural language processing but not computer vision, actually I can still benefit from one of those services if I need it to accomplish one of the scenarios I'm working on. So as a student in computer science, maybe other areas, what's your recommendation based on your experience, but also on where you see AI go, the way things accelerate in research, in industry? Do you have recommendations for the students here?
Yeah, on your blunt question about whether to be a generalist or specialist, I would say very simple answer, one word, yes. Yeah, basically, of course, if you really want to have impact, and many of you are thinking about or going through graduate program, for example, to get your master's and a PhD, it is a good idea. Getting a PhD is a good idea because you can actually get specialized enough on a particular area to really make a difference on that area. That's what I did. That's many people that you get your PhD and you know a lot about something small, but you really know a lot. So you can make that something small change or be big. But then don't get too focused on that. Go deep, be a specialist on whatever ticks you or wherever you think you can make an impact. But always save some time and some of your brain to think broader. What if I could do other things? How could this be combined with something else? For example, as you saw at the caption bots, the idea that I produce a natural language description of an image, it's clear that I need to have some combination of machine learning, computer vision, and natural language processing. So I need top experts with PhD level capability in all of these areas. But if you look at the team working on those, everybody actually knows a little bit about the other topic as well, because otherwise you can't put it together. So in short, I would say, yeah, go deep into whatever ticks you, but save enough of your brain to also look into other things, not randomly. I would say, for example, the way I approach and many of my colleagues approach is think about scenarios. Think about, for example, how can I make a person who can't move anything speak, right? Think of a scenario and think of the technologies that are in there. If the space in which you are a specialist, there's a space for that, you go there and you try to motivate other people. As John will tell you, for example, the eye gaze project came out not because me said, we shall do eye gaze. It's because a bunch of engineers and researchers saw that scenario. They start talking to each other and say, look, you do this, you do that, you do this other thing. We can make this work. And it was actually a hack. It was a hackathon inside the company. And that's how now the project is more formal, but it started as a hack. It started as a bunch of people within the company, because actually, just to say a word about Microsoft, the company actually motivates us to do such things. So we actually set a whole week during the year where you're not supposed to do your work, you're supposed to hack. So you came up and you put those things together, and you're always going to need to do impactful things, more than one specialty. But then one person is really hard for one person to be a specialist of everything. So go deep, but also look at other things so that you know how your thing can be combined with others to achieve impact.
Thank you.
All right.
We have a question.
Yeah, thank you very much. Neil from Mexico.
Hi.
Thank you very much for your talk. I think it's a very nice and interesting vision on ICT.
Thank you.
Talking about a general question, you show us different models of research and from the point of view of Microsoft. My question concerns the interaction between industry and academia.
Mm-hmm.
From your point of view, in which instance or timing it's nice to work together, and in which others you are going alone, for instance, for Kinect technology, you drive it alone. What's your point of view on that?
That's a good question. In the same way that very good actually, the same way that I talked about the managing research, there's different models. Interacting with academia, there's many different models. This is an event. We're here, we put this event together, we bring you to talk to us. It's an opportunity for you to talk to each other, talk to us, and exchange our ideas. For example, you may have an idea about something about a project, and suddenly you may find a colleague, even from another country, right, not necessarily Mexico, who has had similar ideas, and you can interact that way. So there's many models. There are models where our researchers go to conference and talk to you and talk to their colleagues, and that's how we get to interact. Another model is that through those interactions, we discover the brilliant students that some of them are here, that we can go and hire as interns, not just us, Microsoft, but the whole industry, right? There's an enormous market for interns. So I would recommend anybody as a student, if you have an opportunity to do an internship in a company that invests in advanced development and research, do that. You're going to learn a lot, because the real world is always a little bit different, to put it mildly, from what you see in your courses. So, and you learn a lot from that experience, including broadening your views a little beyond what you're studying. So the students that get the internships can be also a bridge to talk to the professors. Also, we have Evelyn is in our outreach team, and the outreach team has a whole portfolio of initiatives and programs, including programs, for example, as Paula mentioned, where we team up with other institutions such as FAPESP, and we actually try to help foster, including putting our own money to help support research in some particular areas. So there is many mechanisms, and Microsoft is actually very open to interacting with you and discussing project possibilities, right?
Question.
Hi.
Thank you very much for the inspiring presentation. My name is Francisco Cantú, Tecnológico de Monterrey.
Oh.
So my question is also about collaboration, but this is with academia rather than with respect to industry. And when I say academia, I would like to refer to the AI communities, the logic-based community, the connectionist-based community, the Scruffis, the NEEDs, and the various AI communities around the world. So how is Microsoft dealing with the different AI communities in order to advance these projects that are changing the world from my standpoint? And how are you, what are the strategies that you have to help them work together, if they are working together? And what would be the strategies that you have in mind in order to take advantage of the talent on the various AI communities around the world in order to achieve these goals?
That's a very good question, in particular because AI is such an important and fast-growing area. But I'm going to take that one and pass it to my friend Emily.
I was going to say, I think this one is coming to me.
This is really directed to her.
Yeah, so actually I'm very glad that you asked that question. So we've started, indeed, even in the outreach program and working with our researchers, at looking specifically in the context of AI, what can we do working with the research communities. We started some events. Of course, we go to some conferences, the existing one, AAAI, ISHCAI, NIPS, and again, well, not again, but of course, when we talk about AI, it's a broad area, and people, as you mentioned, there are different communities, sometimes in silos, so we are looking at all that. And we have also started some specific programs which are just nascent, and I think, I don't know if Katja is in the room, but Katja is just behind you. And so we have an effort that we will talk a bit more. Katja will present it, I think, Friday morning, which is one aspect of AI. Of course, many researchers here are working in the area of AI. So, but there are specific programs we are starting. And would love to get your input. We are really here to have also a conversation. That's what is going to make this event very rich. And also for people who are streaming, this is a talk which is being streamed. If there are some ideas, please reach out to me.
Thanks.
I think we can take a last question.
Hello, Rico. Thank you for your speech. I'm Pedro Alves from Unicamp. I work with the Laboratory of Applied Security and Cryptography.
All right.
And if you don't mind, I would like to make my question in Portuguese. It's okay?
Oh, that's fine. For me, I still understand Portuguese. I prefer a carioca accent, but São Paulo is fine.
Desculpe. Você comentou sobre a questão da criptografia homomórfica, no caso, parcialmente homomórfica. A gente tem bastante trabalho sobre isso, em especial eu sei que a Microsoft Research também tem, né? Mas nós não temos soluções aplicadas, nós não temos produtos que realmente utilizem isso hoje em dia. Na sua opinião, falta teoria para ser desenvolvida ainda, para que isso seja possível, ou é uma questão da indústria abraçar essa abordagem e trabalhar em cima do que a gente já tem?
Okay. Can I repeat your question in English the way I understood? Your question is a very good one, because I mentioned on partial homomorphic encryption, and you're working on that area. So your question is about what more do we need to do to embrace that kind of technology in the real world. And you probably know, most likely better than I, that homomorphic encryption is incredibly expensive computationally, right? It takes a lot of computation to do a very simple operation, because I'm trying to do that on encrypted data, and there's a bunch of reasons for that. So there isn't that much that you can do. However, in the same way that you can do on a normal computer, but in the same way that deep neural networks take a lot of computation, and we're building them, and we're using technologies such as Catapult to be able to do them in practice, the same thing applies to partial homomorphic encryption. Because of the power of the cloud, I can actually do some operations fast enough that they're not going to be a bottleneck in your application. You can still build some kind of new database access thing or something, and it's relying on partial homomorphic encryption. So I think there is, back to your question, what is there to be done there? I think there is room on the theoretical side of cryptography to do a little more research on how can I evolve it and find some reduced complexity solutions. The same thing happens with deep neural networks. It started as very generic and very complex, and now, because we are restricting the format of the matrices that connects the neurons from one layer to the other, we're now using constrained shapes that reduce the number of active nodes, then the complexity is going down. So first you start with something brilliant, but it's too complicated to compute, and now you start reducing. I think there's a space to do that in homomorphic encryption, and also ways to, knowing that I have to do a lot of computation, can I implement them efficiently on very parallel architectures, like tens of thousands of parallel processors doing something? Can I use that to accelerate PHC, right? And I think the answer is yes, but we don't quite have all those answers yet. So it's very much an active research area. Yeah.
All right,
All right.
with that, we're going to thank Rico very,
All
very
right.
much.
Thanks, folks.
And
All right.